Hey everyone, welcome back to Swift Fundamentals. Today we're diving into protocols delegates for data passing, as well as we're going to learn a little bit about subscripts for custom data access. By the end of this video, you'll understand how to enforce subscripts with protocols and how to use delegates for efficient data flow. Let's go ahead and dive on in. So we're going to create a protocol, and we can do so by using the protocol keyword, and then by giving it a name. Just with like classes and structs, these names actually have to start with a capital letter. So I'm going to call this one indexable. So when we create a protocol, we're going to be requiring any kind of reference or instance of this to conform to this type. All right, and in our protocol, we're going to create a subscript by using the subscript keyword. Then in the brackets, just like within functions when we have our parameters here, I'm going to say index. We're going to say that's going to be an integer, and then we're going to return a string value, and then we're going to use the get keyword. So essentially what we've done here is we've created a protocol with a declaration requiring any conforming type to define a subscript. Let's go ahead and create a structure next, and we'll call it string collection. So struct string collection. And we're going to reference our protocol by using the colon here, and I'm going to type out indexable. So that protocol that we created just above here. So we need to make sure that this structure conforms to the indexable protocol. That's why we're getting this error. So let's go ahead and create a private let of items, and we'll say that this equals an array. We can fill it with some strings here. So I'll put Swift, maybe playground. Need to wrap that in quotation marks. Maybe we can have a couple more as well, maybe protocols and delegates. Cool. So I'm just going to fill it up with some random words. So this is at an array of strings that the subscript will provide access to. And we're going to now reference our subscript, and you can see here that we have our index one already set up. So I'm just going to press return in order to autofill that, and then we're going to create some code. So essentially we have this subscript implementation now, and we're going to want to return a string from items at the specified index. That's what we created that indexable for. So let's go ahead and create that logic here. We'll say guard, and then we're going to have an index here. I'm going to say greater than or equal to 0, double ampersand for the and, index less than items dot count. We'll create an else statement. We'll add our brace, and we're going to go ahead and return out of bounds. So this is going to ensure that the index is valid. Otherwise, it's going to return that out of bounds error message. And we're going to go under this brace, and we're also going to have to return the items within that index. So this is going to return the element at that specific index. So let's go ahead and see this in action so we can kind of walk through all the steps here. So let's create a collection. So I'm going to say let collection equals string collection. Okay, so this is going to create that instance of the string collection struct that we've defined above. Let's go ahead and now print collection, and then we're going to reference the number one item in the array, which is not the first item in the array. The first item in the array is represented by 0. So in an array, so in our Swift playground protocols delegate, Swift would be 0, playground 1, protocols 2, delegate 3. So this is going to print out playground. Perfect. Now let's go ahead and access something, maybe number 10, something that's way higher. We only have those 4 elements. So let's see what happens when we print collection and then reference the 10th element in the array. It prints out of bounds. Perfect. So by using this index here, we're basically saying, hey, we're going to make sure that this is within the bounds, and I'm going to print what that element is. Otherwise, this return is going to go ahead and say out of bounds. All right, now let's look at the delegate pattern, which lets one object pass data to another. Delegates are perfect for managing data flow in Swift. So let's go ahead and create a protocol here using that protocol keyword again. So let's go ahead and create a protocol here. I'm just going to use that keyword. I'm going to call my data delegate. And I'm going to have this be conforming to any object. I'm going to create my brace here. So this is the protocol defining a delegate method for passing data. We're going to have a function in here. And we're going to say did receive data. We're going to add a parameter here. We're going to say underscore space data. We're going to say that this is going to be a string. Cool. So let's go ahead and so this protocol requires a delegate to handle received data with a did receive data method. So let's go ahead and create a data provider class now. So I'm going to say class data provider, add my brace, add some space, and let's go ahead and say weak var delegate, and we're going to go ahead and say data delegate. We're going to use our optional value here. So this is going to be that delegate property to notify another object about any of those data updates. We're also going to create a function in here. So I'm going to say func fetch data. We don't need anything within these parameters here. And this is going to basically simulate fetching any of the data. So let's say let data equals delegate pattern in action. So this is just going to be our sample data to be passed. And then we're going to say delegate question mark dot did receive data, and we can see that we can use our autofill feature here. And we're just going to say that the data is just going to be the data. We don't need to specify anything else. So this is going to call the delegate method if it's set. So here data provider has a delegate property. When data is fetched, the delegate is notified. And now let's create our data receiver class. So we've created our provider. Now let's create our receiver. And create one more class, data receiver. Whoops, should be one word there. Perfect. And we are going to have this conform to the data delegate. So I'm going to use colon data delegate. I'm going to add my brace here. And let's make sure that it conforms. So we're going to put our function did receive data. We can use our autofill feature there to make sure that it's the exact same as our protocol, which is really great when you set up those protocols to make sure everything's uniform, right? Let's go ahead and just have this say print. We did receive the data, and then I'm just going to interpolate that data there. Wonderful. So this is going to print the received data. All right, let's go ahead and test this in action now. So we're going to create a provider. So I'm going to say let provider equals data provider, and then I'm going to create a receiver, and that's going to equal our data receiver. Cool. So let's go ahead and do provider dot delegate equals receiver. I'm just going to use my autofill feature here. So this is going to assign the receiver as the delegate. And then we're going to do provider dot fetch data. So we're going to call upon that method. So this is going to call fetch data, which triggers the delegates method in the receiver. And we should have an output. We did receive the data, delegate pattern in action, which is what we had set that to be. Again, this was just sample data. So if you were, kind of sharing this information back and forth, you would actually have that real data, not just the string that we had created. So by combining data provider and data receiver, we've implemented a basic delegate pattern to pass data between two objects. Alrighty, let's go ahead and combine everything together. And what we're going to be doing is we're going to be creating a system where a delegate responds to updates made through a subscript. So we're going to start with our protocol here so everything can be uniformed. And we're going to call this advanced data delegate. And I'm going to say this can be for any object. Let's go ahead and add our declaration. We'll just have it be a function did update item. Cool. In our parameters, we're going to go ahead and say at index to be an int with value colon string. Wonderful. Let's now create our class advanced data provider. Okay. We're going to create a weak variable again. We're going to say delegate, and we're going to reference that advanced data delegate. Let's go ahead and unwrap that again. So this is going to be our delegate to notify changes in data. We'll then create a private variable of items. Let's have this equal, I don't know, some fruits, apples, bananas, grapes maybe. So this is going to be the array of items that we're going to manage and update. Now let's create that subscript. We're going to say index, which is an int, and we're going to return a string. Let's add our brace here. And we're going to go ahead and say get and add one more brace. And this is going to be our read-only subscript to fetch items, which is why we're using the get. We're going to say guard index. We're going to use our logic from before as well, equals 0 and index less than items dot count. Then we'll do the same thing as before, else. And here we're actually going to return invalid index. Okay, we can go ahead and close that off. Let's go to the next line, and we'll go ahead and return our items in that index array. Cool. Outside of the get, we're going to go to the next line, and we're actually going to create a set. We're going to add our brace there. I think I might have too many brackets right now, but we'll see at the end. I should be good. I should be good. So this is going to be the subscript setter in order to update those items. So we're going to say if index is greater than or equal to 0. We'll do the double ampersand index less than items dot count. Create a brace here. Items within that index equals new value. We're going to then reference our delegate. We're going to use our optional here dot did update item at. We're going to reference that, and we're going to say at index. Then the width, we're going to say new value. This is going to notify the delegate about the update. So here the subscript manages the items and notifies a delegate whenever an update occurs. All right, let's go ahead. Now that we have the provider, let's create a class for the receiver. So because that one was called advanced data provider, let's go ahead and call this one advanced data receiver. Wonderful. We'll make it conform to the advanced data delegate that we've created above. Go ahead and add our brace. And here is where we'll need to have that function, right? Because we had that protocol, we need to make sure that it always lines up, right? So we're going to make sure we have our function here, did update item at. We can just use the return key in order to autofill all of that information immediately. And let's go ahead and for this code, we'll just use a print statement here. But of course you could always, when you're dealing with the data, do whatever you want with it. So I'm just going to say item at index. Then we're going to interpolate our index. And then we're going to say updated to, and then we're going to have the value within here. So this is going to print the index and the updated value as well. Alrighty, let's go ahead and see this in action. So I'm going to say let advanced provider equals, and then from here we're going to have our advanced provider and let advanced receiver equals advanced data receiver. So this is going to create the data provider and the data receiver. Go ahead and now say advanced provider dot delegate equals advanced receiver. So this is going to set the receiver as the delegate. And let's go ahead and now print the advanced, oops, not a string, advanced provider, and let's reference the 1 again within that array. Let's go ahead and now say, I'm just going to scroll so it's a little bit easier to see. And let's go ahead and now say advanced provider 1. Let's update this to now be a blueberry. So this is going to update the second item, so that position 1 in the array to be blueberry now. Let's go ahead and print it just to verify that that has been updated. We can see in our chat it has. Let's go ahead and print it out anyways. Advanced provider, and then we're going to reference 1. Alrighty, so we can see in the print statement that we're saying, okay, I'm going to print out the element in position 1, which if we go back up is indeed bananas. Then we're going to say, okay, I want you to update to this to be blueberry. And when it is updated, we do get that message confirming that it's happened. Item at index 1 updated to blueberry. And now we can print 1, which does confirm and verify that the item has been updated. So with this setup, we can use subscripts to update items and rely on the delegate to notify about those changes dynamically. And that's it for protocols, delegates, and subscripts. We explored how to enforce subscripts with protocols and how delegates make data flow seamless between objects. These tools are essential for clean, organized Swift code. Thank you so much for watching, and don't forget to like and subscribe. And remember, dream big, code bigger. Have a good day.